Hey guys, and welcome to 5.4. In this lesson, we're going to talk about polynomials with several variables. This is important only because students seem to get tripped up as soon as you start adding multiple variables in there. If you just do x or you just do y, everybody's fine. But as soon as you add multiple variables in there, students start to trip up. Some of these problems come from your homework. And just so you know, like on problem number 1, it's just asking you what is the coefficient. And so the coefficient is the number out front, sign included. And so for number 1, the answer is simply negative 17. That's the coefficient of x to the 4th y squared. Okay, so that was pretty straightforward. Now, moving on, when you get to problems like number 2 or 3, you have x and y. All right, so when you have x, or you have more than one variable, you can't solve for or simplify very well. All right, but if they give you what the terms are, you can obviously plug them in and crunch your number. So here, they give you that x is 4 and y is negative 7, and you're simply going to plug that in, and that's going to say 4 squared. And I would open parentheses as a habit, so 2 times 4, and then that's going to be negative 7 plus negative 7 squared. And I say open the parentheses because it doesn't really matter on the first one, but when you get to the last one where the negative 7 is then all squared, if you don't put the parentheses, you get a completely different answer. So be careful with that and just go ahead and get in the habit of anytime you plug something in, plug it into a parentheses first. And then if the next step or two you get rid of the parentheses, it's not a big deal. But you always want to err on the side of caution because you don't want to make careless mistakes. 4 squared is 16. All right, 2 times 4 is 8 minus, or times negative 7 is negative 56. And the negative is going to be squared because it's in parentheses, and that's going to be plus 49. All right, so when you crunch all that up, 16 minus 56 plus 49, you can do it all at once or in pieces if you're doing it by hand. That's going to equal 9. Okay, similar on 3. I'm going to take 5, plug it in, y, it's going to be negative 3 cubed minus 5, negative 3 plus 3. Okay, negative 3 cubed is going to be negative 27, so that's 5 times negative 27. All right, negative 5 times negative 3 is going to be positive 15 plus 3. Okay, you add all that up, or you crunch those numbers, and you're going to get negative 117. Okay, on 4. Here, they're asking you several questions in one. First of all, they want you to make a list of all your terms. Well, my first term is here, second term is here, third term is here, fourth term is here. Okay, so for my first term, I got x squared y cubed. Second term, I got negative 3x cubed y 7th, and notice I included the sign. 3, I have, my third term is 3y, and my fourth term is negative 3. All right, now they want to know they want questions about each of these terms. First of all, what is your coefficient for each of these? Well, if you don't see a number, it's understood to be 1. So my coefficient is 1 here, my coefficient is negative 3 here, my coefficient is positive 3, my coefficient is negative 3. Okay, and then your degree. Remember, in a previous video, we talked about the degree of a polynomial. Well, that's pretty straightforward when you only have one variable to deal with. But what is it when you have multiple variables? All right, so here on number 4, the first term has xy, the second term has xy, the third term has y, and the fourth term, the last term, doesn't have any variables. Well, if it doesn't have any variables, it doesn't have any exponents. That one's pretty straightforward. Y to the first, you don't see the exponent, that's pretty straightforward. Now, the first and second term, they both have x and y. Well, when it was just one term, it was the highest exponent, which is the degree of the polynomial. Okay, but if you're trying to find the degree of a particular term, you're going to add the exponents together. So for the first term, it's going to be 2 plus 3, so that's going to be degree 5. And then the second term is going to be 3 plus 7, so it's degree 10. And so knowing all this, you can officially answer the question, what is the degree of this entire polynomial that has multiple variables in it? Well, it's the highest exponent, just like before. It just took a little extra effort to get there, and that's going to be degree 10. Okay? Now, on number 5, throughout this lesson, we're going to repeat a lot of the same things we did in previous videos, but now, again, we just have multiple variables. So when I'm adding multiple polynomials, I just drop the parentheses and get to work. So it's going to be 8x squared y plus 2xy plus 5 plus a negative is the same thing as subtraction, so minus 3x squared. I'm condensing signs. I'm not really distributing signs or anything like that, because this is the only quote-unquote sign change that we're going to have here. So plus 9xy plus 5, and I'm going to take my time because this looks really messy. I'm going to find my like terms. That's x squared y. This is my xy, and then constant terms. Okay, it's always helpful to go ahead and do that. So I have 8 minus 3. That's going to be 5x squared y. I have 2 and 9. That's going to be 11xy, and then I have 5 and 5 is simply plus 10. Okay, and that's as easy as that easy. Okay, and then just like earlier, on number 6, we're going to drop the parentheses in the first one and distribute the negative through the second one. So I got x cubed minus 11xy plus 4y squared minus 11x cubed minus 8xy plus 10y squared. And again, I'm going to take some time and I'm going to find my like terms. I got xy here and here. I have y squared here and here. Okay. All right. So I got this is going to be x cubed minus, it's going to be minus 10x cubed. This is going to be, let's see, that's going to be minus 19xy, and that's going to be 14y squared. Okay, that is it. Okay. Now, number 7, I'm simply going to multiply. I'm going to do one thing at a time. I'm going to deal with my numbers first. And so negative 10 times 5 is negative 50. You have x to the 6 times x cubed. And remember, when you multiply like bases, you add the exponents. So x to the 6 times x cubed is simply going to be x to the 9th. Y to the 4th times y cubed is simply going to be y to the 7th. Don't overthink it. Don't let a problem intimidate you. Okay? Now, on number 8, you need to know that this is the same thing as writing 8x plus 7y twice. In fact, it's imperative that you know this, because a lot of students, they will see a problem like this, and they will say, well, that's going to be 64x squared, that's going to be 49y squared, and that's going to be my answer. That's half true. But if it's half true, that means it's fully wrong. Okay? So there is a middle term that often gets left out, and if you don't include it, it's going to be wrong. So yes, now I'm going to take the 8x, and I'm going to distribute it, and then I'm going to take the 7y and distribute it, and that's going to be 64x squared. This is going to be plus 56 xy plus 56 xy, and then 7y, that's going to be 49 y squared. Okay, I do need to clean this up. So 64 x squared plus 102 xy plus 49 y squared. Now, if you don't include that middle term, it is wrong. And that's why I would encourage you, anytime you see something written like this, where it's written with a squared or even a higher exponent, I would write it out. Make sure you write all your terms and then multiply, add, subtract, multiply, divide accordingly. Okay, now last problem, application problem. All right, basically what this is saying is that you have a formula that I've given to you here in orange, that if you take an entire tree that's just been cut down and you put it through the mill, this is how much one trunk of average diameter and length should give you. Okay, and it tells you that diameter is x, length is y. All right, it says a building contractor estimates 250 board feet or 2,500 board feet of lumber is needed for a job. The company just milled a fresh load of 15 timbers. All right, that's important because this formula is just for one timber. So whatever I get, I got to multiply by 15. Okay, that average is 10 inches in diameter and 18 feet in length. So those are my numbers. So I'm going to say 1/4, x is 10 squared, y is 18. All right, again, this harkens back to some of the first ones we did in this lesson. They give me x, they give me y, I'm just plugging in. And so x is 10, y is 18, plus 4, 18. Okay, and so you're going to crunch those numbers. All right, this is going to give you 162. Remember, this is one timber, and I have 15. So I'm going to take 15 and multiply, or I'm going to take 162, multiply it by 15, and that's going to give me 2430. And now I'm ready to answer the question. The contractor says it's going to take 2,500 feet. It's going to take 2,500 board feet to finish this job. I currently have, based on the 15 timbers, 2,430 board feet. Is that enough? Well, no. 2,500 minus 2,430 is going to give me 70 that I'm missing. So 70 additional board feet are required. All right. I hope you got something out of this video. If you have any questions, please reach out, and I'll see you in the next video.